Hi, Robert Chuckrow here. I want to talk about and compare the metric and fractional systems of measurement because there seems to be a lot of confusion about that. And what I'm going to end up saying is that both systems are useful in their appropriate realms. And for example, the metric system is very useful in science, whereas the fractional system is very useful in everyday life. So what it comes down to is we have units of measurement of things like length, time, volume, weight, etc. And if we are measuring something and it doesn't fit into an exact number of units, and we want to get a more exact measurement of it, we break up those units into factors. So if we can break the units up into factors of 10, a tenth, a hundredth, a thousandth, etc. Or we can break units up, basic units of measurement, up into fractions of 2, factors of 2, I should say. A half, a quarter, an eighth, 16th, 32nd, etc. And so those are the two basic systems. The first system is called the metric system because the basic unit of length is a meter. And so metric is the word that's used to describe that system. A good example is this ruler, which has both the metric system on top and a metric scale and a fractional scale on the bottom. The metric scale has centimeters and millimeters, which are 1/10 of a centimeter. So each centimeter is broken up into 10 divisions. At the bottom are inches, and each inch is divided up into a half, a quarter, an eighth, and a 16th. And then there are other rulers which are very much more precise, which can go to a 32nd of an inch, even a 64th. And of course some rulers go not only to a 10th of an inch, but to a 100th of an inch. And you need a magnifying glass to read that, the 100th of an inch. Both are useful. Both are useful. In science, we do a lot of mathematical manipulation. And so multiplying by a factor of 10 is very easy because you just move a decimal point one space over. If you multiply by 10 to 100, just move the decimal, add another 0. Or if you're dividing, you take away a 0 or move the decimal point one space over. Fractions are more difficult. So the appropriate method in science is the metric system. And it's very widely used everywhere in the world for science. The fractional system is more for everyday human use. So for example, let's take the monetary system. The highest amount of money that you can have as a bill is $100. I think there are larger sizes that are used by banks. Now probably everything is digital, but ordinary people, the largest denomination they would have is a $100 bill. And then you have, if it were just metric, then you'd have a tenth of a dollar would be next, which would be of $100, which would be $10. And then a tenth of that would be $1. And the coins would be then 10 cents and then 1 cent. And those would be the factors of 10. Well, that wouldn't be very useful or anywhere near as useful as if you had factors of 2. So for example, half of 100 is 50, so we have a $50 bill. Twice a $10 bill is a $20 bill, $20 bill. We have a $5 bill. A $1 bill, we can multiply it by 2, we have a $2 bill. It's not that common, but you see them from every now and then. Then half of that would be a 50-cent piece, half a dollar. And then we have half of that again is a quarter. And if you have a dime, you could have twice that. That would be, half that would be a nickel. So we have all these divisions of two, which end up helping us to be able to deal with things more conveniently. When you go to the grocery store, and let's say you want to buy a bottle of seltzer, well, the bottles of beverages are usually in liters, measured in liters, which is the metric system. And so you have a liter bottle of seltzer, let's say. But then the next larger size, if it were truly metric, would be, instead of a 1 liter bottle, would be a 10 liter bottle. And then the next size would be a 100 liter bottle. You wouldn't even be able to carry a 100 liter bottle. Maybe some people could, but I wouldn't be able to. If you then instead had a smaller size, which would be a tenth of a liter, that would be a very small size, probably not worth even using. So we have, instead of only a 1 liter bottle, we have a 2 liter bottle, a factor of 2 above. And then we have a half liter bottle, and often you see quarter liter bottles. And I've even seen 1/8 liter bottles of certain things that are used in smaller amounts. Similarly, for, let's say, boxes of things, a box of let's say, crackers. There's going to be a box of crackers, and then you look elsewhere on the shelf, there'll be a box that's twice the size. And that's because people come in single units. And so if you're single, you're buying for yourself. If you're married, you buy twice that. You might buy twice that amount. If you have children, you'd buy 3 or 4 times that amount. But you wouldn't be buying 10 times that amount. It's very unlikely that it's you and then 9 other people. So that's these examples show where the fractional system is really very valuable when you're dealing with people and everyday needs rather than scientific endeavors. Both systems have their realms of usefulness and are very good in those realms, and I would think are here to stay. Thank you.